talk of this session, let me introduce you to Vladimir. He is an IT teacher and award-winning open source advocate, sharing his knowledge with the next generation of software engineers. So let's hand over to Vladimir.
Thank you everyone for coming to my session. My name is Vladimir. We have a big, there's not many of us here, so can we have a big round of applause to volunteers, presenters, and organizers for putting the conference together. It's a massive, usually thankless task, so if you see a volunteer, please tell them thank you. And thank you for coming to PyCon. The conference is here because you are here, so don't underestimate your effort of actually just coming here. So my name is Vladimir, and I live in Brisbane. And I contribute and I teach open source, among other things. So I have one question for you. Did you hear that AI is coming to take your job? I don't think people in ballroom 1 heard that, so they all went there to give their job to AI. But just imagine what it is to be like a student in 2025. Anyone student? 1, 2, excellent. I'll ask that question again. Anyone is a teacher? Here we go, more teachers. Well done. I think that's the biggest amount of teachers I ever had in my presentation, so great. Worry not. We're going to tackle it and we'll see if actually AI is there to do anything good for us, or maybe just good as saying to answering the question like how many pies in PyCon. Just go and ask your favorite chatbot if you're interested in the answer, but they're pretty much the same. So, and I was wondering a couple of years ago, a slow year, I was wondering what it's like to be a teacher. So I went to website of the local TAFE, which looks like you're going to become a rock star if you go there. And I became a teacher a couple of years ago, certified teacher. Before that, I was doing the private sessions for the government and big companies for the open source technologies for about 10 years, but I officially received a diploma and I was teaching different things, certificate for introductory, diploma for more advanced and kind of introduction to development, and advanced diploma, which is a pure proper development diploma. I got a very nice and cool looking badge. And from the open source perspective, I was teaching things like Python, Node.js, React, C#, and also Drupal and WordPress. I got a cool workstation, and I put my tractor calendar to it to make it a bit funkier. And it was a simple exchange. So TAFE, it's a college subsidized by government, and what they do is they actually ask in industry more than anyone else is what they can do to improve that. So exchange was simple. I would give them the industry experience and feedback, and they're going to give me a teaching experience. And I'm a true believer that developing a habit of mentoring others is one of the best ways to actually becoming a better developer. So today's agenda, we're going to talk about living in the age of generative tools, even though as AI. I'm also going to be talking about what I wish I learned in uni. We're going to talk about good development practices, and we're also going to talk about future of Python and open source in academia, how it's looking. Okay, so the goals are how to adapt teaching, mentoring, and learning to new technology trends. Also, as I said, the exchange was given industry advice for academia. I run my own business. I do employ people, including developers. So I think I'm in a good, and I did employ students from TAFE. So I think it's I'm in a good position to actually reflect on that. And we're also going to play some mythbusters because there's a lot of things happening in the industry that kind of semi-true, half-true, or not true. Anyway, so this session is useful for students, for teachers and mentors, and I also would like to give some advice for IT professionals like myself. So 20 years ago, I graduated from uni, and the life was a bit different. So we used the real-life libraries. We actually had the books. I have one in my backpack, but not sure how many people do have. Git was just invented a year ago. There was no GitHub. There was no social medias. There was no chatbots, well, openly available. Python 2 was only 5 years old, and Django was just released. Famously, a couple of years before that, Steve Ballmer, who was the CEO of the company called Microsoft, called Linux a cancer. So things are a bit different now, 20 years in. We do have internet for things like books. We do have things like GitHub. We do have things like GitLab. And we have social media chatbots, and Django is at 20 years old. Get into there with the big boys like WordPress and Drupal in terms of age. And things change in the industry as well. Microsoft acquired GitHub, the biggest open source repository in the world. And from the recent news, Microsoft just open sourced BASIC. That's BASIC for the Commodore 64, the one they used to charge $25,000 per license back in 1978. And they also donated DocumentDB, which is their alternative to MongoDB, to Linux Foundation? I think so. Yes, to the Linux Foundation. So that shows something. They actually have some technologies they don't want to keep supporting open source, but actually donating them to open source. So again, things have changed. So I'm sure you have some questions for me when we go there. So I would like some audience participation to keep this a bit alive and wake up. So when you see this sign, there are only a few of them. You can ask me a question. So let's practice that. Anyone wants to ask me a question? Oh, thank you. So I put it together. I danced it down to 6 takeaways. Number 1 is open source. Open source tools are widely used in academia. Python, we use Python libraries to teach Python, but also other tools that are listed before. Programming languages, frameworks, libraries, CMSs, IDEs, and just software is actually way more widespread than it was 20 years ago. As I mentioned, some of the technologies I taught and some tools I used, they're pretty much all open source. Which wasn't the case in 2005 when we used to get the MSDN subscription from Microsoft to install Visual Studio as well. I mean, it's not like we're using all non-proprietary software, but I think it's a good mix, and I'll tell you why. The question, though, I heard from my colleagues throughout all my career, and even back in the uni, is why free? Why free? And the answer is simple. It's reusability. We don't have to write things from scratch. It's giving back things that you actually can open source, and it's testing. You have a lot of free testers for things like Python to go and help. And there are a couple of myths hanging around about open source. For example, open source is not secure. You can see different news articles lately, not really putting it together on open source itself, but you know, things happen, and open source has been blamed for a few things that not necessarily their fault once or twice. Usually it's bad practices, but that's just one of the myths that people asking me. Open source is not popular, which we definitely can say it's not true, especially when different governments are actually saying that we will start open sourcing most of the platforms. Switzerland did it last year. And open source doesn't pay, which I guess Red Hat is one of the companies that can actually tell you that it's not true. And it can become a great model. And that's not just an example, that's probably one of the most popular ones. So I like to see that the students getting exposed to industry tools that might cost a lot of money, but at the same time they would like to be exposed to the alternatives, because once they hit the market and start working like I did, I wasn't sure what was alternative to Microsoft Visual Studio, for example. And Corals, of course, it's a large competition, especially in the proprietary vendor software, and it's a steep learning curve with variable quality of documentation for open source. Right? We have great tools like Visual Studio Code, which is free now, open source by Microsoft, but I also like to give students an alternative. For example, PyCharm, which is software you paid for. Here you go, we have some fans of PyCharm. Yeah, which is a great alternative. I like JetBrains. It's my personal choice. I don't advocate for it. But again, it's something that I would like students to know, so they can actually go and choose what they want. So my recommendation, if you are a teacher, advocate open source. Like tell them there are tools, you don't have to force them to use them, but there are tools for office management, there are tools for image manipulation, there are tools for just playing files. They're free and open source, and just knowledge of that might might go the long way. Advocate by doing, actually go and maybe read the issue queue. You don't have to know to see, but it's a good idea to know where Python source code lives, so you can actually start navigating, maybe reading the issues, what's happening, what people are doing. It does take time, but it's also a good practice to have. Play Mythbusters. If you hear something, make sure the person who refers you to a specific thing, like blame open source on something, has a decent reference, or two, like a good journalism, rather than seeing some social media post. And build your portfolio. That's another thing I would talk about open source, because once you contribute in stuff, commenting on stuff, and just helping out, you get in some credits one way or another. It depends on the industry, depends on the technology, but not necessarily get GitHub things. But it's, for me as an employee, it's a great tool, because the first thing I'm gonna ask a developer I'm hiring, what's your GitHub account? I don't want to see like activity commits every day, but I'd like to see what you're interested in or what you committed. Right? So number 2, source control is the afterthought. It was afterthought when I was graduating, and these days the TAFE curriculum actually doesn't have that you need to know Git to graduate. So you can graduate without knowing what Git and GitHub is. So it's not a depending on the teacher, you might never use Git as a developer, which is, I think, is ridiculous. And today, Git is actually more than source control. We have tools like GitHub, GitLab, and Bitbucket from Atlassian that actually provide way more things. You can plan, you can do a security scanners, automation. This day they all sell AI assistants to actually help you with coding. You can actually do coding in your browser as well. So those tools are great to learn and use either on daily basis or whenever you can. So the few actions I took is actually I use source control for each subject. Although I wasn't required, I asked students to download the code or to do a Git clone, or at least familiarize themselves with interface. For example, all the tasks I was putting in Git, so they can actually go and start familiarizing yourself with the interface. And I also do, for the last 3 years, I do annual address to the students. That's one of them, I think that's last year. So I basically talk about similar things, but just with the student focus on why they need to know that, rather than try to jump on just the proprietary tools. And a few recommendations if you haven't used source code or you know someone who doesn't, ask them to create an account. Make sure they use it often. For example, just create a monthly routine saying what's new with the Python, if there's something changed, or Django, or something like that you use. Read release notes. Some release notes are bad, but some release notes are very good. For example, here's what's new in Python. Who read that when the new Python is released? Few people. That's good. One of my favorite examples is Bootstrap. They put a blog, they put a good release notes on GitHub, and it's actually a good read. It's very non-technical. I mean, unless the specific task goes very technical. It's a front-end framework, but it's a very good example, like industry standard of how to write your release notes, so you actually know what's happening. Peruse issues. So if you go to Python, I haven't used C for 20-something years, right? And the Python is actually written in C, but I can actually go and start looking what the issues are. They're not necessarily you need to know C to actually go and contribute back to Python. Django, similar thing, although those issues are just links from the other system, so I'll actually start familiarizing myself. Oh, Django actually used different issue queue. How can I do that? Oh, okay, so there's a tracker. So then if I want to contribute more, I'll go and start familiarize myself with documentation, developer guides and stuff like that. Is it easy to read? If it's not easy to read, how can I contribute more to that? And basically every system, open source system I can contribute, Docker, Bootstrap, WordPress, they all have first-timers issues. So if you go to Python, there is actually an easy tag. You can click on easy tag and yeah, you can see the easy stuff and things like doc. Glossary alphabetical order is only for English. right? Something for multilingual audience. There's some things not documented. So you can actually go and start looking at the issue queue and maybe start contributing without even writing the C code. Same goes for Django. There is a link in Easy Picking, so you can go and see the Django issue queue, familiarize yourself, and see there is also a bunch of documentation or easy JavaScript fixes or something like that, that you can actually go and contribute back. Maybe it affects you. That's how I started contributing. I found the bug and tried to contribute back. But if you are familiar with the process, it becomes much easier rather than, starting from scratch where you feel like a student again. And all the systems I mentioned have similar stuff. For example, WordPress has a good first bug tag. Number 3, documentation rules. Reading is a skill that we are losing. This year, people read less books than last year, and way less books than they read 10 years ago. We can go into details, and it's not necessarily, one way to look at things, but that's the reality. And I have a person coming to me at the WordPress meetup and saying, where can I learn WordPress? I was like, well, that's a very broad topic, but I would recommend to concentrate on one of those books. And they just interrupted me and said, I don't read books. Like, literally, the person said to me, I don't read books without even, trying or doing that. That's the reality we're living in. Another thing is quality documentation is rare, especially for open source project. That's a lot of investment for not much of feedback. So reviewing documentation these days should not be an afterthought. But again, it all comes to the point where do we actually have time and budget to do that? But successful projects do have good documentation. Python is one of them, Django as well. So I recommend to go through that checklist when you're actually thinking about documentation, either for private project or for public. I treat them all the same. I actually not allowing merge requests anymore without documentation in the code. Is your documentation easy to find, easy to understand? Is it easy to reference, easy to follow, and easy to share? As a teacher, I would like to have a piece of documentation and pass it on someone who can follow it and do it properly rather than reading it and not understanding a thing. Contributing the same thing, even easier than contributing the code, contribute documentation. Easier, it's not necessarily the thing to refer to and compare documentation to a code, but I find that, helping documentation, there's less people contribute to documentation than contributing to code for the open source project. So it's easy when to start when contributing is actually documentation. There are guides for Python and for Django to do that. There's a minimal technical knowledge required to start reviewing. For example, is getting started page make sense or can be improved for you as a first-time reader? And the reality is, it is always gets neglected. I'm a big contributor to Drupal, and one of our things is documentation, and it's not very good. And guess what AI models are reading and getting trained on? Yes. So recommendations, read and try to follow the documentation. Update it if you can, and write tutorials. If you wrote a tutorial and you think it's a good documentation, just contribute it back. It's actually a good way to recycle your tutorials. Some systems allows you to put a reference to your original tutorial, but it depends on the system again. Again, check the Django documentation. It's pretty good. There's also a way to get help. In case of Python, it's a Discord, so join the Discord if you have questions. There are always good people there to help you with even basic introductory questions. And I always tell the students, remember, there are no bad questions. Symfony Fast Track, it's a great book I show as a good example of introduction to technology. I translated it into different language, but I found this one of the best books, which is free and available. And apparently Laravel documentation, which is PHP framework, is another good example of documentation, and people do show the saying that it's one of the best documentations online for the open source project. Is also something to reference. I always like to reference different projects when I see something very good and kind of cross-pollinate with others. So I know you have more questions for me. I already basically covered it, but that's a good question. So let's talk about reliance on generative tools. They sometimes often called intelligence. People say they're here to stay. A lot of people refer to them as not sustainable. But also one thing is G in GPT, for example, stands for generative. So I had a few examples with students doing good and bad things with things. For example, tic-tac-toe, someone built it from scratch. We were doing object-oriented programming and when I asked show me your class, they didn't know what class was, but they had a running software. Someone copied the answer, including when you ask something ChatGPT, it replies to certainly. So they copied certainly as well and put the answer in the assignment. Security best practices as well. So GPT tools are not very good at analyzing your code and making it more secure. Good examples. VS Code documentation, someone didn't know how to configure things in their IDE. They just went and asked ChatGPT and followed the example. Creating quizzes, some students just had the curriculum and they asked I think they asked Gemini to kind of use their notes to summarize it and to build the quizzes for them. 10-question quiz every week, and I think that was pretty impressive. And if you're not subscribed to Hard Fork, the podcast by New York Times, the latest podcast is about actual education, and it has much more examples of where students rely on things. So Hard Fork, I would highly recommend the podcast. So the last episode is about education. Okay, so my personal reflection is they're okay to use. I actually encourage students to use them. They're very bad at analysis, especially analysis of large open source project, and they're very bad at refactoring. They do sometimes do good things, but in majority of cases, I tend to spend more time with them if I'll try to rely on the tools. And there are a couple of philosophical questions I kind of gathered over the last couple of years. Am I hiring a software engineer or prompt engineer? That was the first question when they just appeared. Building industry has to follow the government regulation, but we as IT, we don't have unions, we don't have anything. So when it comes to the regulations, yeah, it's kind of a personal choice and ethics, which I don't think we have enough in the IT industry, but again, this is something to answer for yourself. And the last one I heard actually from that podcast with one of the professors, he said, if we're telling now that the prompt engineers will replace developers, how quickly do we think the prompt engineers will be replaced by AI? So a few things, AI detection miserably failed over the last 2 years in academia. There's too many false positives and students not very happy and teachers not very happy, so a lot of the tools were scraped. And there are a few things I found are good for AI to battle. Group assignments, pair development, and code reviews are great. Using real life examples, for example, I got a real tender for Great Barrier Reef report, and just depending on what sort of stuff they were doing, like WordPress or Django, I just asked them to do different things from this report, and I thought it was great. But the basic tender was converting this multi-hundred page PDFs into web. And there is also like platforms like Tender. Victoria has built-in for Victoria tenders. You can go and download those tenders and see which you can actually, so you can introduce students to the real life projects straight into uni, which I don't think that happens often. We used to write everything from scratch, but I think it's a time for us to actually give them the real life examples and introduce them that. So, and open source contribution, as I mentioned, is a great thing to have. I'll just go to the issue queues. So ability to read, I already mentioned on that. I quickly skip through that. So I find that students are bad at reading errors, but lately I found my clients are really bad at reading emails as well. So I think we all as a humanity kind of reading less and less. Even we can't read an error as a student, then we learn how to read an error, improve on it, and do better. But again, reading is something that I would recommend. So a few recommendations: start lesson with code, introduce find an error exercise, and read books. One of the books I would recommend is The Power of One. Blowing the Whistle on Facebook, which does talk about a lot of education, and it's about by Frances Hogan. And she worked in Yahoo, Google, and then Facebook. So I think it's quite an interesting book about the industry and education as well. Attend industry events, like we're at the conference, so I already asked if you're a teacher and student, so sometimes it's hard for students to attend the conference, but there are other things to do. There are cheaper conferences like DDD all over Australia, there are meetups, there is GovHack that you can attend, so you can watch videos online, you can promote local meetups, and attend local meetups as well. For example, in Brisbane we have Python meetup. You can present a meetup as the volunteer, or and tell us what you learn as a student or as a teacher. Let's summarize. So for the students, I would say be curious, build your portfolio, get into open source early, and attend the local events. For teachers and mentors, help students to work with new tools, contribute to open source, and present at local events. And for my colleagues in IT, I say present definitely at any event if you can. Promote your skills, use your experience, and teach people what you wish you'd learn when you were in uni or in school. Cross-promote your skills as well. If you think something is better than you're currently using, just get it out there. It can be a 5-minute presentation at a meetup, but just do it. So, and hopefully we can all improve the situation which we are currently found ourselves in, where at the moment PhD's enrollment currently in decline in Australia. Thank you very much. I'm not sure if we have time for questions, but if not, find me after the session. I will be hanging around. And thank you for listening.
We have time for like 1 or 2 questions if anyone has a burning question right now. No? Yes?
Thank you. That's a fantastic talk. Thanks, Vladimir. As a student and someone who also teaches as well, it's really good to get both sides of that from someone, so thank you very much for that. We talked a lot about generative AI and, as a student, the compulsion to then go and use it. But firstly, do you really blame students, one, categorically, for using a tool that does talk back to them and interacts with what they're saying in a way that is quite human-like in its nature, in the way it can explain things back to them. But further, don't you think there's also room in the errors of the languages themselves to be clearer and plainer? Python has a quite readable error handling mechanism that does tell quite explicitly what the problems is, as does Rust, but I'm unfortunately the victim of some C# and .NET, which is less forgiving in that space. Did you have any thoughts on that?
Sure. So presenter here before, I think 2 sessions before that, she said, I only can speak from the experience because I have 10 years of experience, and I think it's a brilliant phrase to have. So we do need an experience, regardless of where we are. And to answer about tools, I do encourage to use any tools they can, even if cheat if they can. Like, I mean, I'm not promoting it, but this is a way of hacking the system. This is a way why a lot of us actually learn how to do things, just to get around things. So I really encourage, and I would like to see that happening, because for us, it's also a way to learn. If you stop learning, you're not really a good teacher anymore. So I think, and the students, again, if you listen to this podcast in the end, they actually recorded the students how they use the tools differently. I think it's amazing, because we as teachers can learn way more from the students, because they're much better at using the new technologies than we are. And I think this cross-pollination would always be there. Again, I can see a lot of, I think we as humans as well, very good at scaring, saying that's it. We don't need any more developers, but that's not necessarily true. So I think experience is great. The best example I can give is, people start learning Python, start learning Node.js, and they have an error, and they raise a hand and say, I have an error. I was like, which error? They're like, I'm not sure. I was like, can you read it for me? So you sit with them, and you teach them how to read an error. The second time, they raise a hand and they say, I have an error. And I was like, what is this? And this time, they read an error, but they didn't analyze it. So you teach them how to analyze an error. And the third time, they raise the hand and say, I think I know how to fix the issue. And when you see this progress, is like, that's what inspired me to teach more. Because this process, yes, it's hand handling. How one of my managers said on a project, you know, like art of IT is you have to find the responsible for the mistake, you have to push them under a bus, but then you have to lie with them, get up and fix it as a team. So I think it's a collective effort, and as an individual, we only can do that much. As a team, we can do way more. Well, thank you very much.
Thank you, Vladimir. Can we all give our speaker another round of applause? Here is your mug. If you